Good afternoon, YouTube. Today's video, we're going to take a look at the Skil 1825, and I'm going to try to replace the failed brushes in these. Apparently, the brushes do wear out, as they do with all these brushed motors, and in this case, as you might have read on the internet, if you own this device, the brushes are unavailable, discontinued. However, I have been told that these Bosch brushes, and I'll leave a link in the description, do fit this device. Unfortunately, unlike some of the other routers I have owned, they don't have little screw plugs here where that you could just screw these out and replace the rotors. So I'm going to crack this thing open and get a better idea as to what's going on inside here. I did start unscrewing some of the screws here just to get to make this a little bit quicker, but I have not taken it apart. And of course, because the brush replacement isn't a simple unscrew the plug and swap it out, this is probably going to be slightly more difficult because I'm going to be left in a situation where I've got to remember where all the pieces are. There is a schematic online. I have found one of those, PDF. I'll leave a link in the description for that as well. But in the meantime, I'm going to get to work on this and see what I can come up with as far as replacing the brushes. And as you might imagine, once this thing is open, I am going to take the liberty of, I do have some 1200 grit sandpaper here just to clean the body of the motor in case there's any soot or crap on there, just to clean it up so when the brushes go back to work, they've got a better surface to ride on. So I do have a screwdriver here. There's a, I believe it's a Torx wrench. I'm sorry, a Torx screw head. I have some electrical connections, some electrical pliers. Because it appears, if you look at the brushes, they appear to have some kind of electrical connection, so I might have to make some pinching on there. But in the meantime, I'm going to get started on this. It looks like I need a flathead screwdriver. Alright, so this is for the collet lock, and obviously I'm going to take some time to make sure I put all the right pieces in all the right places. So here's your collar lock. There is a spring in here. Please be mindful of the orientation of the spring, because putting that back in, I'm sure, is going to be a nightmare. And I'm just, as I take these out, I'm going, if they're not all the same, I'm obviously going to try to denote where I found them and what they look like. These are pretty long. And the ones on the bottom of the base here appear to be pretty accessible. I don't think that's the case with all of them. Some of them seem to be a little bit deeper. And in my first run, I needed to use an Allen key torque wrench, an Allen key style torque wrench, just to get a little deeper in there. But I did find a longer screwdriver that might make this a little easier. So these are from the base by the collet. I want to see if these are any different. And of course, as everybody knows, the downside to dealing with these things is the wire. Yeah, these are shorter, so I'm going to keep these separate so I can remember that they go on the body. This goes on the bottom. But yeah, what I was saying was, the one thing to be mindful of is when you try to put this together, obviously the hurdle is remembering how the wiring is set up, because there are usually channels for the wires. And this does appear to fit in here. Let me see. Nope, having a little bit of a problem. Oh, there we go. So hopefully these are all the same size, so I don't have to babysit who they are and where they live. Just going to get this cord out of the way. so it doesn't knock over my camera studio. And hopefully when I crack this open, there we go. Ah, yes, not so bad. So that was a little bit more simple than I had anticipated. I'm just going to place this on the side here with my other screws. So what I'm looking for are where these guys reside. And I'm not going to open that until I'm sure I can replace this. So, yeah, this is not going to be fun. So here's the motor. And this, in fact, is, here are the bearings. This is, in fact, the part that I did want to hit with my, this 1200 grit sandpaper. But this is where these brushes make contact. So before I do anything, I'm just going to clean this up just so there's a nice surface and there's no corrosion on here anymore. Or less corrosion. I'm probably blocking your view of this, but I'm sure you get the idea. Let's give this a little spin. And this is just to make the contact between the contacts and the motor a little bit cleaner, because typically this carbon buildup, because it isn't a conductor, it can and should affect the performance of the motor. So once this is clean, hopefully not only will replacing the contacts work better, but it should make the performance a little better. And I do see the brushes in here. Looks like there's some more unscrewing to do. So I'm going to, oh, perhaps not. They appear to be right here on top. Here they are. So I do need a Phillips head. I'm going to switch this out for a Phillips head. And fingers crossed, this is a relatively quick and easy swap. This circuit board is trying to slide out, and I don't need additional things to fix, so I'm trying not to pull that out. One more thing to remember to put back. Okay. So there's a plate that covers this one. I'm gonna pull this thing out, hopefully remember the way it goes back in. I'm only gonna do one at a time so I can keep better track of exactly what's happening. All right, so that appeared to slide out relatively easy. This contact point right here goes down on this side. If you look somewhat closely, you can see, interestingly enough, I do want to say that this motor does need to be in there when this is replaced, because there's a spring on here, and you can see that these were completely obliterated compared to the new ones. So hopefully this direct replacement does work. Yeah, you can see that there was shot. But because this is spring activated, if I put the brushes in first, I won't be able to slide this in because I have no way of restraining or putting tension on these before I put it back in. So I am going to need to pull both of these out. And remember where these parts go. This light just popped out, so. And technical difficulties. And if all fails, I'm probably going to pause this video and rewind it so I get a better idea as to how everything was configured when I started so I can put it back together. So I'm just removing this other retaining clip that's on top of this second brush. Okay, that's number 2. This clip comes off. And the brush just pops out with a screwdriver. There we go, number 2. Put this over there. So now it appears that this motor needs to be set back in prior to the brushes going in. So this is the new brush. That's the trigger. And I'm just going to put some pressure on the head of the brush and pop this in. And that appeared to work. Wow. That's the new one, and where's the other new one? That's a dead one, and here's the other new one. And hopefully you can see this. I'm just going to give you a better angle. So there's a pin here, and that pin lines up in here with this pin. So I'm just going to show you. So I'm going to put some pressure on the rotor head, slide it in, and these do appear to fit despite Skil indicating that they were discontinued. So that seems to be a direct replacement. So I'm going to put this retaining clip back on. It pops right in. Put this little screw in here. It's unfortunate that these were designed almost to be disposable, because it's pretty apparent to me that they don't want you fixing these, just by virtue of the difficulty involved in taking it apart and putting it back together. But for less than $15, if you do have this Skil 1825, it's a lot less expensive than replacing the entire tool. I'm going to try to use this Torx wrench because It seems to want me to. Much better. So there's an option to use a flathead screwdriver or a Torx wrench. It seems that Torx is a little bit easier. Here's the second retaining clip. And this just pops in over the second one. There we go. Screw this one in. So now that this is back in where it's supposed to be, I'm going to assume that this is properly reassembled and that I can put this tool back together and expect it to work. Provided, of course, I can remember where all the pieces go. And the wiring, that's my biggest concern, is the routing of the wiring. So here's my trigger. This LED light goes in here. Yeah, so my concern was the board in here and the way it was configured. So I did print out the schematic for this just to see how that's configured. So I've got to figure out how that goes back in. It appears to go in here. I know this cord comes out of here. This trigger comes in here. I've got to route these cables properly. They go in here. This cord goes in here. That's in there. do apologize for how long this is taking. I didn't expect this to take this long. I was hoping this would be a quick fix, but I had a feeling that routing all these parts would be the limiting factor to getting this thing back together. So here's my diode. There we go, there's our button, trigger. Here's our power cable. This goes in here. Okay, that trigger works. Power cable and our adjustment screw goes right in here. And it seems to snap back together. And this little wire needs to go back in here. And I think that should be our fix. So I'm going to put this back together and very frighteningly plug it in and see if it works. Just going to screw in the 4 corners first, just to make sure this is locked down. And one more. Make sure there's no spare parts lying around. Make sure all these are locked in. Locked. 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 And now the head screws. 1, 2, 3, 4. And one way to keep sure of the way this head goes back together is you'll see that there are these guides here. And obviously if those line up, there's a good chance that the configuration is correct. That are about to get short-circuited and electrocuted when I turn this thing back on. But hopefully these brushes do work, and if they do, you can easily save yourself $150 by replacing it, although the new 14 amp Skil is quite a beautiful device. And I'm not going to put the shaft lock back on. I'm just going to test this by plugging this in. And I'll save that for later. That is over here. So I'm just going to see if this works. Make sure the trigger's not on. And give it a whirl. Perfect. Works. So now I just need to put the shaft lock and the screw back on, and we're good to go. So that's it. Like I said, I'll leave links in the descriptions of this schematic, replacement parts, and I'm back up and running. Thanks for watching. Please subscribe, and look forward to the next video.